Hello everyone, my name is Yifan Zhang, and today I will talk about the homework 7 and the problem 7. It's about the function of zt that contains n1t cosine omega t plus theta and plus n2 sine omega t plus theta. Well, theta is uniformly distributed into 0 to 2 pi. And the n1 and n2 are all y-sense stationary, and they are all independent. The first question is to find nz, because n1 and n2 are y-sense stationary, so it means that n1 is a constant and en2 is also a constant. So when we need to find EZT, we just put this function into that, and then we can separate that by this part, this part, this part, and this part. So there are n1 is en1 multiply e cosine omega t plus theta, and en2 e sine omega t plus theta, and this part is theta 1, and this part is 1 divided 2 pi from 0 to 2 pi, and cosine the combinative, and the second one is similar. So because it's all odd function, so this means that this part is 0 and this because from 0 to 2 pi there will be a odd function, so the part above the more larger than the part that is positive, and the part that is negative is the same. So this part is 0 and this part is 0, so the result is 0. The second function is that zRz t1 and t2 is about EZT1 and EZT2. It's just similar to the previous part. Just put t1 and t2 into that and separate it to 4 parts. So I mean this part times this part, this times this part times this part, and this to this, and this to this, and this to this. They are 4 separate parts, and they have all different function. And we just like the previous part, we multiply each part, and we can get that this part can transfer into this. So by the function of this one times, we can transform it to the part that they add each other. So like this. And the last three parts is also the same, and we calculate each other and each one, and we can see that the result is like that. This is n equals to z rz tau. So we can say that zt is also y-sense stationary. The third question is about Rz. So we need to find Rz0. So when t equals to 0, we just take this to this, and so we have this part. And there's okay, and if zt is y-sense stationary, we have proved in the above question. So zt is also y-sense stationary, and that's all. Thank you.